Okay, so here we are doing Newton's second law of motion. As we've talked about in class, there are 3 laws total. We've already done the first one, so let's do this second one. So this is a guy pushing a big bale of hay down the road. This looks like kind of where I am from, so it's very familiar to me. Okay, our essential questions for today's video. How do we calculate the acceleration of an object? How does the acceleration of an object depend on the net forces acting on the object? And how does the acceleration of an object depend on the mass of the object? So just think about what you may already know about those things, and then we'll go on. So as always, you can pause, you can rewind, you can, I guess, fast forward if you need to see what you need. You can always pause and translate words too if you need that. So understanding motion. Before we dive into Newton's second law, let's understand motion. So we can describe motion as one of the following. So we've kind of talked about this in class, but not maybe use these exact words. So stationary means it's not moving. So something that is sitting still. Something that is moving at a constant speed is moving without speeding up or slowing down. So it is just going the same speed as it's going before. And then accelerating is either speeding up, slowing down, or changing direction. So a lot of times people will use the word accelerating to mean speeding up, but it actually also means slowing down or changing direction. Okay, so Newton's observations when it came to these things. So obviously the famous English physicist and mathematician Isaac Newton, we've talked about him before, studied how objects move. So he observed that a change in an object's motion or acceleration depends on the object's mass and the amount of net force acting on it. So remember, the mass is the amount of matter that is inside something. And if it has more mass, it needs more force to be able to move. So it depends on the mass and the force. So what is affecting how fast this person can push this weight? So this device she is pushing has weights attached to it. And so what is affecting how fast she can put that or push it? It would be how much weight is on it. So how many weights have been added to it? What is the mass of them? The more weights that are on top of it, the more mass it has, the more she's going to have to push to get it to move, which is kind of the point of doing that exercise. Okay, so Newton's second law of motion. So remember, the first law was that an object at rest stays at rest unless acted on by an outside force. And so this is the second law. So Newton's observations became one of his 3 laws of motion. So the second one is that the net force is equal to the mass times the acceleration of the object. So the amount of force you need is the amount of mass times the acceleration. So you take how much mass is in something, how fast it's going or how fast it's changing, and that gives you how much force you need. Okay, so mass is the amount of matter in an object is its mass. Mass is typically measured in grams, so G, or kilograms, kg. Mass is closely related to, but is not the same as weight. So gravity affects mass by giving it weight. So the reason that adults too, often get confused and use the words mass and weight to mean the same thing when they don't is because on Earth, they do mean the same thing. So if you have a mass of 70 kilograms, your weight is also going to be 70 kilograms on Earth because gravity is pulling you with like the base level of gravity. If you were to move to the moon, which we may do someday, your mass would be the same because you are the same amount of person, right? So your mass would still be 70 kilograms, but now the moon is much smaller. It has a lot less gravity, so now your weight is going to be maybe 12 kilograms because the moon has 1/6 of the gravity of Earth. So your mass is going to stay the same everywhere you go unless you get smaller somehow, if you lose weight or if you lose a leg or something. But your mass will stay the same regardless of where in the universe you are. Your weight depends on what gravity is. So here it says weight can change depending on the gravity of an object, of where an object is located. However, the mass will not change. So your mass stays the same. Your weight depends on what the gravity is of the planet or the place where you are. It keeps clicking my video. There we go. All right, so acceleration. Acceleration occurs when there is a change in velocity over time. So acceleration is very similar to speed, even though it's not the same thing. So since velocity is a measure of both speed and direction, anytime something speeds up, slows down, or changes direction, acceleration is occurring. So again, in just common, conversation, people will say accelerating to mean speeding up, but it can also mean slowing down or turning, changing direction. So acceleration is typically measured in the unit meters per second squared. So you would say this car is accelerating at 7 meters per second squared. And that means that they are accelerating at a rate of 7 meters per second. So here it asks, when does acceleration occur? It occurs when there's a change in speed, either speeding up or slowing down, or changing direction. There, it didn't change my camera. All right, so forces. We've talked about this before a lot. So push or pull, acting on an object is called a force. And forces can change the motion of objects by moving the object, stopping them, or changing their direction. And remember, the unit used to measure force is newtons, symbolized with a capital N. So make sure you always include your unit. You can't just say the force is 10. You need to say the force is 10 newtons. So here we have this dandelion. It says, what force is causing a change in motion in the image above? So what force is pushing those seeds out into the air? And it could be wind. If it's natural, it could be something coming by and blowing the seeds. We used to do that when I was little, like blowing the seeds around. So it's some sort of push, some sort of breath or wind that's pushing it. All right, so let's take a brain break. So think about the scenarios pictured. So we have this one on the left, somebody playing baseball, and then we have this one, people on a sled. So explain to someone, or just think to yourself, because obviously there's nobody near you. So think about what is happening in each picture, and think about the words force, mass, acceleration, and motion. So what is happening when these boys are playing baseball? How does this relate to force and mass and acceleration and motion? And then over here, these people on the sled. I would much rather be over here playing baseball. I don't do cold weather. But if we decided to go sledding, how would that relate to acceleration, force, mass, and motion? All right, so net force. So this, again, will be a review of what we've already covered. So typically, there are multiple forces acting on an object at the same time. The net force is the sum of all forces from all directions acting on an object. And as we've talked about before, if the forces are acting in the same direction, you add them. And if the forces are acting in opposite directions, you subtract them. So here in this picture, we have kids playing tug of war, much like what we did in class. So if all the children have the same strength, which direction of the rope will move? Why? So if all of these kids pulling on the left and on the right have the same strength, which direction will the rope move? You should know that answer. Okay, so again, we've covered this. This will definitely be a review. We've done this a lot. So here on this one, they're moving in the same direction. So we add them together, 5 newtons to the right plus 5 newtons to the right equals 10 newtons to the right. So remember, when we talk about net force, you always need a number, you need a label, and you need a direction. So 10 is our number, newtons is our label, and to the right is our direction. So here we have 5 newtons to the right, 5 newtons to the left, and so since they are opposite directions, we subtract. 5 minus 5 is 0. So box 2 is balanced forces, and its motion is going to stay the same. And here we have 15 newtons to the left, 10 newtons to the right, and so what would we do? They are opposite directions, so we're going to subtract. 15 minus 10 is 5, so 5 newtons, and which direction are we going to go? We're going to go to the left. So this one is 5 newtons to the left. All right, so let's think of these words. I'll put myself up here at the top. So match the vocabulary term with its definition. We should definitely know these. So which one is the sum of all forces from all directions acting on an object? Which word is that? The sum of all forces. That's going to be our net force. Okay, so net force is our first one. This is a change in velocity or speed over time. So change in velocity or speed over time. That's going to be acceleration. So our first one is net force, the second one's acceleration. The amount of matter in a substance or an object. So the amount of matter, that's going to be our mass. This is a push or pull acting on an object. We should definitely know that one because we've covered it a lot. That's our force. And then process of elimination, because there's only one we haven't picked yet. The net force is equal to the mass times the acceleration of an object. That's going to be Newton's second law. Okay, so we have, what was it? Net force, acceleration, force, no, mass, force, Newton's second law. Sorry, I misread that first one. Okay, so let's talk about a formula. Put myself down here. So we can analyze how net force, mass, and acceleration affect each other by using the mathematical formula F equals ma, where F stands for force, m stands for mass, and a stands for acceleration. So we have net force measured in newtons, we have mass measured in kilograms, and we have acceleration measured in meters per second squared. So that's why we have F equals ma. So you might actually hear some nerds, myself included, make the joke, like Star Wars, they always say, may the force be with you. And so some people will say, may the mass times acceleration be with you. And it makes me smile because it's a science and a Star Wars joke. Anyway, if the mass of an object is 500 grams, what needs to be done to that value to use this formula? So the mass is 500 grams. So what would we need to do with that number? We would need to multiply it by the acceleration. And we don't have that yet. So we just know that the mass is 500 grams. The force is yet to be decided because we don't have the acceleration number. So unless you have both, you can't really do the force. Okay, so using the formula, so a skateboarder with a mass of 50 kilograms is accelerating at 2 meters per second squared. How much net force is acting on the skateboarder? So here we have our formula, F equals ma. We know that the mass is 50 kilograms, and our acceleration is 2 meters per second squared. So what is our force going to be? Remember, our unit for force is always newtons, so we're going to multiply. So 50 times 2, tell me you know that. It's 100. So our force is 100, and our unit for force is always newtons. So our force for this skateboarder is 100 newtons. So this skateboarder is pushing themselves off with a force of 100 newtons. Well, they have a net force of 100 newtons because obviously they are rolling down a road, which is going to have friction. And so they're pushing themselves enough to overcome that friction and still have a net force of 100 newtons. Okay, so let's go ahead and do these practice problems. These are fairly simple. Okay, so we have a mass of 15, acceleration of 8. So you're going to multiply those two numbers together, 15 times 8. And here you can pause the video to get your number and then come back to see if I get it right and to see if you get it right. So 15 times 8, 10 times 8 is 80, 5 times 8 is 40. So 80 plus 40, 120. So this first one is going to need 120 newtons of force to get it pushed. So our second one, 45 times 5. So 45 kilograms times 5 meters per second squared. It's going to need a little bit more because it has quite a bit of mass. So again, you can pause, do your math, and come back. So 45 times 5. So 40 times 5 is 200. 5 times 5 is 25. So 45 times 5 is 225. Right? Yeah. So that's how I do my math. I break it down into tens and the ones. And then lastly, we have a lot more mass, 90 kilograms, but it's not accelerating quite as fast. So you're going to multiply 90 times 2. Hopefully that one's a little bit easier. 90 times 2 is 180. So those are our numbers. You need 180 newtons of force to move whatever object that is. 90 kilograms could be a large person. Okay. So Lance and Eddie, good old Lance and Eddie, are competing in a bicycle race. Lance's bike is 15 kilograms and he is accelerating at 1.2 meters per second squared. Eddie is accelerating at 20 kilograms, his 20 kilogram bike at 0.9 meters per second squared. Use the formula for Newton's second law to calculate the amount of net force each biker is using and who is using more net force to pedal their bikes. So again, this can be multiplication. I'll give you a minute to work through your math. I'm going to have to work through my math too because multiplying by 0.9 is not the easiest number ever. It's not terrible, but it's not the best. All right, so we're going to do 15 times 1.2. So 15 times 1 is 15. 15 times 0.2 is 3. So we need 18 newtons of force for Lance to push his bike. And I think that might actually be Lance Armstrong, the famous bicyclist. So Lance needs 18 newtons of force. And so here we have Eddie. He's got a heavier bike, so he's got a 20 kilogram bike, but he's not accelerating quite as fast. So 20 times 0.9 is 18. Could do that one in my head. So Eddie has 18 newtons of force. And so who is going faster? Who is using more net force to pedal their bikes? Trick question. They are using the same amount of force. Even though Lance has a lighter bike, he's going faster. Eddie has a heavier bike, but he's going slower, but they have the same amount of force needed. Okay, so rearranging the formula. So this gets a little tricky if we don't pay attention to what we're doing. I have taught this so many times. So to find the mass, you divide net force by the acceleration. And there are 3 variations of the formula. So what you can do with this is that if you are given a problem like this, but say you're not given the mass or the acceleration, say you're given the force and the acceleration or the force and the mass, and you're trying to find the other one, you can use this triangle to figure out how to do the math to find the third one, okay? So no matter what you are given in the problem, you are able to calculate the other one based on this triangle. So I'm not even going to worry about, which is, you guys can see me with the screen. Anyway, I'm not going to worry about what it says here. I'm just going to explain it the way I think kids usually understand it best. So what you do with this triangle is you cover up whatever one you are missing, okay? So say in the problem, in the word problem or the question that you are given, say you are given the mass and the acceleration and you're asked to use the force. So you cover that one up and what's left over is mass times acceleration. So that's what you do, okay? Say there's a question where you are given the force and the acceleration, but you don't have the mass. You cover that one up, and it tells you what to do. Force divided by acceleration. So the mass isn't there, so we're not going to worry about it, but we're going to divide the force divided by the acceleration because that's what you already have. That's what you've been given. And then again, if you have a question and you don't have the acceleration, you're given the force and the mass, and you're trying to find the acceleration, you cover that one up and you go force divided by mass. So whichever one you are missing, you cover up and you do the math on the other two. So force divided by mass, force divided by acceleration, mass times acceleration. And so if you were given a quiz or a test or something on this, I would draw this triangle, FMA, divide, times. And it's easy to remember that this is divide because the F is on top. And so you know when you write like a fraction, the number on top is being divided by the number on the bottom. It's the same way here. So F is divided by M, F is divided by A, and then when we write numbers that are next to each other, then they are multiplied. So M times A. So again, if I was given a test or a quiz, I would write this down and then make sure that I cover up whichever part is missing. So let me know if you have questions on that, because that can be confusing, but I've taught that longer than you have been alive. Anyway, so here in your notebook, use the formula variations to calculate the mass or acceleration. So we're going to keep going back to that triangle. So in this one, we are given the force and the acceleration, but we are missing the mass. So we're going to go back. We are missing the mass, and it says to do force divided by acceleration. So force divided by acceleration, 60 divided by 6 is 10. So the mass of this object is 10 kilograms. There we go. So this one, we are given the force and the mass. We are missing the acceleration. We're going to go back. We are missing acceleration. It says to divide the force by the mass. So that's what we'll do. We're going to divide this force by this mass. 150 divided by 30 is 5. So this object is accelerating at a rate of 5 meters per second squared. 150 divided by 30. Here we're given the mass and the acceleration. We are not given the force, so we need to figure that one out. Cover up the force. Mass times acceleration. 60 times 8 is 480. So you would need 480 newtons of force to move this object that much. Okay. So our last one, we have 350 newtons of force and 50 kilograms of mass. We are missing our acceleration, so let's go see what we say. So we're missing acceleration. We're going to do force divided by mass. 350 divided by 50 is 7. So this object is accelerating at a rate of 7 meters per second squared. So again, you just look and see which one am I missing, and then you use the triangle to figure out what to do with it. Okay, so let's do these. Taylor is driving her 1,500 kilogram car down a dirt road at an acceleration of 6.5 meters per second squared. So what would be her mass, I guess? What is it asking? What factors could be causing a difference in the car? Okay. So she is driving this heavy truck, or this heavy car, down a dirt road with an acceleration of 6.5 meters per second squared. And Theo is driving the same make and model, so the same car, down the same road at an acceleration of 3.5 meters per second squared. So what differences could there be in why Taylor is going so much faster? Why is she able to accelerate much more, even though she's driving the same road in the same car than Theo? What do we think? There could be several answers. It could be maybe she's just pushing on the gas pedal a lot harder. Maybe Taylor's got places to go, so she's speeding, possibly. Maybe Theo's an old man, and so he drives really slow. Could be. It could be also maybe Theo's having like some bad weather, right? And maybe it's raining really hard, and so he's trying to be really careful. So there could be a lot of reasons. Why is Taylor going so much faster? Okay, so here I am not going to go through all of this, but you're going to calculate the net force, then use that information to fill in the missing values for mass and acceleration, and you can use the triangle. So see, here's exactly what I would do. If I was given a quiz or a test on this stuff, I would draw my triangle and go from there. So here we have 15 up, 15 up. So what would our net force be? And then since you're missing acceleration, you would divide these, force divided by mass, to get your acceleration. 45 to the left, 25 to the right, so you can figure your net force. You have the force and mass again, and not the acceleration, so you're going to divide the force by the mass to get that number. 5 to the left, 10 to the left, so you're going to add these together to get your force. You are given your force and your acceleration, so you're going to divide the force by the acceleration to get your mass. Here, 15 up, 0 down. Again, you're going to subtract since they're opposite directions to get your force. You're already given your acceleration, so you're going to divide force by acceleration to get your mass. Here, 60 to the left, 20 to the right, so you're going to subtract those two and get your net force because they're opposite directions. Get your net force. You have your net force and your mass, so you're going to divide your force by your mass to get your acceleration, because that's what the triangle says to do. And then here we have 30 down, 70 down. You're going to add those together to get your force. You have your acceleration. force divided by acceleration equals your mass, and that's what you would do. This number divided by this number gives you this number. Okay? Sorry, we went through that really quickly, but hopefully you'll go back and make sure you understand where that all comes from. Okay, the acceleration of an object is directly proportional to the force applied to it. So when the force increases, acceleration increases. When force decreases, acceleration decreases. So when we did the organize it in stations, a lot of you guys really kind of understood this, right? Like you take the weight out of the wheelbarrow, it makes it easier to push, you go faster. You add weight to it, it makes it harder to push, you go slower. It's pretty common sense. So if the force goes up, acceleration goes up. If the force goes down, acceleration goes down. All right, so mass and acceleration, same thing. So acceleration of an object is inversely proportional to its mass. So this means they're opposites. So when the mass goes up, acceleration decreases because it becomes harder to push it because it has more mass. When the mass goes down, it's easier to push it, you can go faster. Okay? So acceleration and force go in the same direction. Force goes up, acceleration goes up. Mass and acceleration are opposite. Mass goes up, acceleration goes down. Just think about like when I'm doing this to this object, is it now easier or harder to push it? If it's easier, you go faster. If it is harder, you go slower. Okay, so in all of these, just think about it, like when you're going through your questions. All right, so 4 cars enter the highway and their masses and net forces acting on them are shown in the table to the right. So which vehicle would have the greatest acceleration? So all of them have a net force of 5,000 newtons. So they all have the same amount of force. And so we know that whichever one's going to have the greatest acceleration is going to be the easiest one to push. So if we have the same amount of force, the easiest one to push is going to be the lightest one. So which one of these has the least amount of mass? That's going to be the coupe, like a sports car, right? So it has less mass, but it has the same amount of force. It's going to go faster. It's going to be easier to push. So just think about that. You always want whichever one is going to be the least amount of force needed. It's going to be easier to push. Okay, so force and mass. If an object has more mass, it will take more force to change its motion. We will watch a brain pop about this because you'll get the example really easily. If an object has more mass, it will take more force to change its motion. If an object has less mass, it will take less force to change its motion. That makes sense, right? Heavier, more massive things takes a lot more force to push because it's harder to push them, right? Something that's light and easy, a lot easier. That's why it's a lot easier to pick up a little kid than it is to pick up like a grown man. So has more mass, it's going to be a lot harder. So if these 2 cars with different masses coast downhill, so they are just rolling down the hill, which one of these will be easier to stop and why? It's going to be the little blue car because it's smaller, you know? And that's why, you know, when you're driving down the road or when your parents are driving down the road, you have to be a lot more careful around like big trucks because it takes them a lot longer to stop because they have so much more mass behind them. So when a big truck is going down the road at 100 kilometers per hour, it's going to take them a lot longer, a lot more force to stop and slow down because of all that inertia behind them. All right, another brain break. So you can do this on your own, possibly. So stack 2 books on a table using only one finger. Push the set of books across the table. Not the easiest thing, but not terribly difficult. Now place 3 more books on top of the stack and repeat step 2. So how would that change, do you think? If you had a stack of 5 books, would you still be able to push it with one finger? Maybe if they're like comic books, right? Like little ones. But if you have like 5 decent sized like textbooks or something, that's gonna be a lot harder because they have a lot more mass. So 2 doesn't take quite as much force, 5 is gonna take a lot more. Okay, so study the 2 scenarios. Which sled will accelerate faster and why? And we're gonna look and see at these. So which of these sleds is going to accelerate faster? So do we think the one with 2 people on it is going to go faster or the one with just 1 person? What do you think? Which one of these is going to accelerate faster? It's going to be the one with just the 1 kid, right? Because it's lighter. It has less mass on it, so it's going to take less force. So this one's going to accelerate faster because it's only got the one person. So here, both of these sleds have 2 people on them here. But this one, we have 2 people pulling it. And on this one, we only have 1 person pulling it. So here we have the same amount of mass, but we have different amounts of force. So the sled 1 is going to accelerate faster because it has twice as much force pulling on it. So it has the same amount of mass, but it has more force pulling it, so they're going to go faster because they have 2 people pulling. Okay, so the Saturn V rocket, this makes me very happy. This is a topic I love. So this is a 5. It drives me crazy when professional people call this the Saturn V rocket. This is the Saturn V rocket that was used to send astronauts to the moon in the 1960s, required millions of newtons of force for its launch. I've seen this rocket in person. It's amazing. Anyway. During liftoff, the rocket accelerated quickly as it traveled towards space while burning off tons of fuel. Why do you think the rocket can continue to accelerate during the launch with less fuel? Why do you think? Think about that. So during liftoff, the rocket accelerated quickly as it traveled towards space while burning off tons of fuel. So as it goes up into space, it is burning fuel. So the longer that rocket is going, the less it weighs because more of the fuel has been used and is gone. So that rocket is lighter and lighter and has less and less and less mass, and it takes less force for it to go. So it can continue accelerating because it doesn't have as much mass in it because that fuel got burned up and is gone. So I love rockets. Okay, so we're going to drag and drop. We're not going to because it won't let me to in slides, but anyway. So we are going to look and see what words might this fill. So a blank makes things move or change their motion. That's going to be force. Blank is the blank amount of forces acting on an object. So net force is the total amount of forces acting on an object. The formula for Newton's second law is force equals mass times acceleration. Good. More mass equals more acceleration when the same force is applied. Yep. So more mass equals more acceleration. More is a word, right? Greater acceleration when the same force is applied. And more force equals blank acceleration if the, what would this be? More force equals less acceleration if the mass is greater. Yeah. So more mass equals less acceleration, more force equals more acceleration. Yeah. Okay, so how can we calculate the acceleration of an object? So remember our triangle. If we're looking for acceleration, we have force, we have mass. What do we do with those two? We divide. So force divided by mass equals acceleration. And how does the acceleration of an object depend on the net forces acting on the object? So how does that change? The net forces change. If the net force goes up, the acceleration goes up. If the net force goes down, acceleration goes down. Because force and acceleration are directly related. How does the acceleration of an object depend on the mass of the object? Remember, that's the opposite. The mass goes up, acceleration goes down, because now it's harder to push it. If the mass goes down, acceleration goes up, because now it's easier to push it. So just, again, always just think about, if I change this, is it now easier or harder for me to push this thing? If it's easier, your acceleration goes up. If it's harder to push, your acceleration goes down, because it's harder. And I think that's it. If you have any questions, email or ask me in class. Hope you have a good day. Bye.